So here's a question. If a toy rocket is launched vertically upward from ground level with an initial velocity of 128 feet per second, so we have initial velocity of 128 feet per second. Then its height, h, after t second is given by the equation negative 16t squared plus 128t. So how they come up with this, they came up with this equation, you'll do that in physics. So it's not the concern here. It's already, the equation is given. There's no velocity and anything involved. It's just h of t, that's the height with respect to time. So if you plug in the time there, you're going to get the h of t. And of course, this is something like this. I don't know but where it is, but I know because of this negative and because of launching, it should be parabola like that. So we graph and see where's the y-intercept and then where's the x-intercept of this function. But should be something like that. So launching up there and then coming back time. So whatever the time is, if you plug the time there, you're going to get the y value. So now part A says, how long will it take for the rocket to return to the ground? So t is what? So when you have, again, let's redraw that. When you have a parabola like this, and then when they launch this at some point, and then when they return to ground, it means the height is equal to 0, right? So when it returns to ground, its height is equal to 0. So we need to set up h of t equal to 0 and solve and see where the time is that it returns to ground. So that's going to be 0 equal to negative 16t squared plus 128t. That's just a parabola quadratic equation that we need to solve it. T. So if you factor out t from here, that's 0. And then that's going to be negative 16t plus 128 equal to 0, right? So either this is 0 or this is 0, right? So one of the answers, t equal to 0. So I mean launches from here. That's time. And then second one, you set this up equal to the negative 16t plus 128 equal to 0. Solve that. If you solve that, t equal to 128 over 16. So what is that? 128 divided by 16. 6 times 8, 48, 8, 4, 1 times 8, 8, and 4, 12. So it's going to be 8 seconds. That's the other. T is equal to 8 seconds. So if it launches up like that and comes down, so this black one was just an example, right? So that's t equal to 8 seconds. So part 1 is done. Cool. And then B, after how many seconds will the rocket be 112 feet above the ground? Now part B, it says after how many seconds it's up high there. Let's say somewhere on here it's 112 feet. So we want to know when it goes up like that, when it reaches to this height, which is 112, how long it's going to take. And then probably we're going to get 2 answers. At least it could be 1 answer if it's high up there. But if it's not, we should get 2 answers, right? So let's solve that. Now, height is 112. So instead of h of t, you're going to substitute 112 equal to negative 16t squared plus 128 t, and solve this quadratic equation. So b is equal to, let's move this one side, and then I'm going to move them to left side, both of these, by adding 16t squared, and then adding again, subtracting 128t. So I'm going to have 16t squared minus 128t plus 112 equal to 0. And then let's solve that. So, I can divide by 16. Both, apparently, these are divisible by 16. So that's going to be t squared. I can simplify it because they're divisible by 16. Minus, we already did that, we got 8. T, and then 112 is 16 less than that. So it's going to be, that should be 7. 112 divided by 16 should be 7. 7 times 6, 42. 2, 4, 1 times 7. 7 plus 4, 11. So 0. That's plus 7 equal to 0. So if you factor this out, t times t is equal to t squared. What two numbers you multiply, you get 7, and you add them, you get negative 8. It's negative 1 and negative 7. If you multiply them, you get positive 7. If you add them, you get 8. And then so either this is equal to 0 or that is equal to 0, because product of these two are equal to 0. So one of them t equal to 1. If you solve out, the other one t equal to 7. So two answers. T equal to 1 and 7 means after 1 second and after 7 seconds, so it's going to reach to that 112 feet above ground altitude. So that was part B. And then part C says, how long will it take the rocket to hit the maximum height? Now, we want to see when it reaches the maximum height over here, what the time is. So to get this done, what we can do, we know that this is the vertex, the maximum height, right? If you find the vertex, if you find the axis of symmetry, which is negative b over 2a, that's t in this case. When you were doing this, they were saying x equal to negative b over 2a, but here independent variable is t, so t equal to negative b over 2a. So negative b over 2a is going to give you this number, and then that's the time. And if they're asking what is the altitude, that's the vertex, that's a y value, then you need to plot this t instead of this t, and then over here, and then solve for altitude. So let's get negative b over 2a for this. Again, I'm going to write the equation here. Equation was, that's part C now. It was h of t equal to negative 16t squared plus 128, right? So the axis of symmetry, t, would be equal to negative b over 2a. That's equal to negative b. Oh, that's t there. So this is b. And this is a. C is equal to 0. So negative b is going to be negative 128 over 2a. 2 times negative 16. And then negative divided by negative cancels. 128 divided by 16 was 8. So this divided by 16, 1. This divided by 16, 8. Because we divided that earlier. So what's left? 8 over 2. That's equal to 4. So t equal to 4. It's going to be reach the maximum height. That's right here. That's t equal to 4. And then, so that's what they're asking. If you want to know what is the height, then you have to plug t into this. You need to plug t over there, 4 over there, and also 4 over here. And then part D says, what is the maximum height? Okay, part D, that's what they're asking for, part D. And then, so to do the part D, what do we want to know? What is the maximum height when t is equal to 4 seconds? what we're going to do, we're going to plug this 4 instead of, so you're going to have h of t, this equation, so instead of t put 4, h of 4 is equal to negative 16 times 4 squared plus 128 times 4. H of 4 is equal to 4 times 4, 16, 16 times 16 is negative, it's going to 256, but there's negative in front, negative 256, plus 4 times 128, 4 times 8, 32, 2, 3, 2 times 4, 8, plus 3 is 11, 1, 1, 1 times 4, 4, that's 1, 512. And if you subtract that, h of 4 is going to be equal to 256. That's feet. So we figure that this altitude here is 256. So as you can see, it's not in scale. This is half, but it doesn't show it's half. So 256. And then there's another part to this. Graph the path of the rocket. Oh, we already graphed it earlier. So when we were doing it. So we found these points. We found these two x, in this case, t-intercepts. So it was, one of them was 0, the other one was 8. And then we found this maximum. So that's all. But we even have more information. When it was 1 and 7, we had these were the altitude. But that's not needed. So it's already graphed. Okay, this problem is done.